3, 4. Hello and welcome to C# Programming on .NET. My name is Brett Robley and I teach at Cal State University Fullerton. The class is ISDS 309 and this is a first program that we're going to take a look at tonight. This first program will just give you kind of a sense of what C#, the language, looks like and some basic ideas surrounding programming. We'll be using Visual Studio 2017, a Microsoft product that's free. We'll be using the Community Edition. And we're going to create a new project. I won't give you all the details. We'll create what's called a console app. We'll name it a first program. Visual Studio will put some files together and it gives us a template of our first program. So in this file we have some statements I'm going to delete. We'll just kind of clean this up so we can start fresh. Now, I'm trying to keep it simple, so I deleted one of the keywords and I'm going to reformat the document, pull everything to the left. Okay, now let's get started. So C# is an object-oriented programming language, and so the idea of a class is central in the theme of object-oriented programming. Every C# program lives inside of a class. And so what you see here on line 4, 5, and 9 is called the class program. The curly braces bound what's inside of it. And what we're creating now is called a method, which is also known as a function. It's kind of where the execution starts and where we put commands to do things like displaying messages on the screen or doing calculations or storing data, things like that. So in C# there are two kinds of classes. There's an application class, which is what you're looking at right now, and then we will use the class construct for other types of organization in our programs. But for today and for this program, we're just going to create a single class, an application class. Now the way that you know it's an application class is it contains a method called main. And that's what you see on line 7. So every C# application has only one class that contains the main method. And I'll talk about those other funny looking words in a future lesson, but for now, let's go ahead and just start outputting some text to the screen. So this console.writeLine, which is a mystery to you, is the way that we actually output information to a display console so that the user who's running our program can actually see something. Up at the very top on line 1, we say using system with a capital S. And that is a library or actually part of a framework of software that's already been written for us by professional programmers that we're able to tap into so we don't have to learn everything about the computer in order to program it and start using it. Now what I'm demonstrating here is not necessarily object-oriented programming, although we are making use of the console object and in the console object's writeLine method. But it'll be a few lessons before we actually get into designing our own object-oriented code. But in the meantime, programs like this one run from top to bottom. When we write statements that are intended to be executed, the program, when we actually execute it, will start at the very top, line 7, and it will work from top to bottom. So it will get to line 11, where it will output hello world, and then line 12 and line 13, so on. And it will just go from the top of the page to the bottom unless we do something to intervene. And the way that we intervene is to use some other facilities of most programming languages, which include what are called branching statements and looping statements. So when we talk about the program executing statements top to bottom, we're talking about the thread of control. And to change the control of the program, we might use a branching statement. An example would be an if statement. If this is true, then do A, else do B. And so we can actually test the values of certain memory locations, which we name, and we call those variables. And we can change the course or the control of the program based on what we have tested. A loop gives us an easy way to express something that we want repeated. So if we want to count from 1 to 100, then we can use a loop, and computers are very good at doing that kind of thing very quickly. So right now I'm going to create a loop that will count from 1 to 100, and we'll display that on the screen. I won't explain all the details, but we can create this so that you can get some feel when you see the program run as to sequential statements. That's the top to bottom. The branching statements, the if statements, which allow us to change where a program is going. And so it will execute some commands and not execute others based on the decisions we make and the branches that we take. And then we have the looping statements, which allow us to do things repetitively. Now, what I'm doing here is I am introducing a second loop, and I'm going to go through 100 numbers, but I'm only going to print every 10th number. And this will allow me to demonstrate how I can combine a loop, the for loop, with an if statement, a branching statement. Okay, so now let's put an if in here and let's test and say, hey, if this is divisible by 10, exactly, with no remainder, so x mod 10 equals 0, then we're going to display. Otherwise, we're just going to loop around again, and we're going to keep incrementing our counter. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll test every time if it's evenly divisible by 10. When we actually get to the 10th iteration of the loop, the if test will be true, and we will display that number on the screen, and then it will continue on 11, 12, 13, 14, until it gets to 20, which is evenly divisible by 10. And we'll print that on the screen. The last loop is just going to be identical to the second loop, only this time I'm just going to display every fourth number. And again, you can see the construct there in lines 28 and in lines 34. The percent sign is a special operator. It's called the Modulo Divide. And basically, it says if x divided by 4 equals 0, meaning there's no remainder, then we found a number that is evenly divisible by 4. Okay, so now, oh wait, hang on. That doesn't go there. All right, I'll finish this comment, but I need to move this up. It needs to be inside that curly brace on line 39, not outside of it. So console.read, this is a special method that when we invoke it or when it executes, it stops the program and waits for the user to type something at the keyboard. And so we generally do that just to stop the program so you can actually see the display. So there you see the 100 numbers. That's the first for loop, the second for loop every 10, the last for loop every fourth character. All right, that's all for this. Thanks for joining.